Now that we talked a bit about the natural and anthropogenic causes of climate change, it's time to get some perspective on this, on recent global warming, according to the latest scientific information that we have, at least when the ink was dry in your textbook. Part of the warming in the last century is due to increasing levels of greenhouse gases, but although CO2 has increased by about 25% in the last century, the warming that we have experienced is smaller than it should have been, taking into account only the CO2 increase. Natural climate variability and volcanic eruptions between 1880 and 1920 and between 1960 and 1991 may have kept the warming lower than it might have been without those volcanic eruptions. The effect of those eruptions, plus waxing and waning of solar activity, incoming solar radiation, may have put the brakes on the warming and not allowed things to warm up as much as they would have otherwise. We have newer and more sophisticated mathematical models now that are able to better filter out the so-called noise of the natural variability of the climate to see if the forcing agents, both natural and human-caused, are causing the warming and to what degree. Interactions between Earth and its atmosphere are so complicated that it's really difficult to unequivocally prove that the Earth's present warming trend is entirely due to increased concentrations of greenhouse gases. This graphic sort of takes the noise out of the climate system to indicate how the warming might have been in different scenarios. Other than the thin black line, which is actual observed temperatures from 1860 to about the year 2000. The green means warming with only greenhouse gases alone. The blue means greenhouse gases and aerosols, because aerosols tend to thwart the warming a little bit. And the red line is greenhouse gases, aerosols, and variability in solar radiation. So scientists sort of went back in time, about 150 years, to kind of look at how the warming would have been if we could have filtered those things out of the climate system. This is what the new climate models can now do. The Intergovernmental Panel on Climate Change is a prestigious group of 2,000 leading Earth scientists that reports and makes conclusions every few years based on research and mathematical models. In 2007, they issued their fourth assessment report, which stated the following: that most of the observed increase in globally average temperatures since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. In the report, the term very likely means a greater than 90% probability. So since the middle of the 20th century, there is a greater than 90% probability that the warming we have experienced since then is anthropogenically driven. There are different global warming projections based on different levels of greenhouse gases, different scenarios. Mathematicians and climate scientists can tweak the models, so to speak, to say, okay, if greenhouse gases go up only this much, then maybe we're going to warm up that much in the next century. Doubling the concentration of CO2 in the next century, according to their findings, would likely produce surface warming in the range of 2 Celsius to 4.5 Celsius over current temperatures, with the best estimate being about 3 Celsius, somewhere in the middle. If the warming is only experienced at 2 degrees Celsius in the next century, it would actually be 3 times greater than the warming that we experienced in the 20th century. So even if our warming in the 21st century is only 2 Celsius over the levels of the year 2000, it would still be 3 times greater than the warming that we experienced in the previous century. Warming of 4.5 degrees Celsius would probably have potentially devastating effects worldwide. Now, don't think that governments aren't looking at this with respect to public policy and international relations and the geopolitics of this. Even our own Central Intelligence Agency, the CIA, is looking at this, because if warming causes ocean waters to rise and floods out hundreds of thousands of people in different parts of the world, especially in the poorer parts of the world, that is a national security issue any way you slice it. This is a different graphic showing different scenarios of warming based on different CO2 concentrations, or different, greenhouse gas concentrations. If, for the sake of argument, we were able to cap the lid on the emission of greenhouse gases to levels that we were experiencing in the year 2000, then the resulting warming in the next century would be the orange line. It would be about a half a degree Celsius. But here's the problem. The biggest growing economies of China and India are increasing their greenhouse gas emissions. In fact, China has exceeded the United States now. They are now the #1 country in greenhouse gas emissions. So the worst case scenario is obviously the A2 scenario, and the next worst case scenario is the A1B scenario. So the scientists used computer models to run different scenarios based on the level of greenhouse gas emissions and how much the warming how much warming might occur as a result of different greenhouse gas emissions scenarios. There are uncertainties about greenhouse gases, however. Currently, oceans and land absorb about half of the human-produced CO2. How this is going to change if warming continues is not exactly known, but current models suggest that warming will decrease the oceans and the land's ability to absorb CO2, and they might even be new sources of it. That's not a good thing. If we reforest areas that were deforested, that could slow that process down. It's difficult to know what steps countries may or may not take with respect to public policy to reduce CO2 emissions. Now, China has indicated that they, at least in principle, support the goals in the 1997 Kyoto Protocol. Problem with that is that they're the biggest CO2 emitter. So to put that cat back in the bag, I don't know how that can possibly be done. We banned chlorofluorocarbons back in the 1987 Montreal Protocol and the 1990 Montreal Protocol, and substituted them with hydrofluorocarbons, which unfortunately have also been shown to be greenhouse gases, and they are increasing in use. So the law of unintended consequences is CFCs we thought were bad, we banned them, replaced them with something else, but the something else we replaced them with are now found to be greenhouse gases. So it's a law of unintended consequences. Also, methane is a greenhouse gas, and it's 20 to 30 times more effective than a carbon dioxide molecule. Nitrous oxide molecules stay in the air for about 150 years, and the biggest sources of nitrous oxide molecules, nitrogen fertilizers in agriculture, and increased grazing of cattle. Changes in greenhouse gases. This tries to look at a little bit of history in the past 10,000 years, with the inset being, say, the last 150 years since the Industrial Revolution. This is an IPCC graphic showing the hockey stick, so to speak, in the last 10,000 years of carbon dioxide, methane, and nitrous oxide molecule increases in these critical greenhouse gases in the last 10,000 years. How about the question of clouds? How do clouds affect the climate system? Well, clouds can reflect incoming sunlight back to space, and that tends to cool the Earth. Clouds also emit back to Earth infrared radiation, which tends to warm the lower atmosphere. So the effect of clouds is going to depend on the cloud type, the thickness, the height, and the optical properties of the clouds. The high, thin cirriform clouds tend to have a net warming effect. Lower stratified clouds, real thick clouds, tend to promote a net cooling effect. Current satellite data confirm that overall, all cloud types combined together tend to have a net cooling effect on our planet. Additional clouds in a warmer world would not necessarily have a net cooling effect. There's also research ongoing on condensation trails. Those are those clouds that are formed behind a jet aircraft high in the atmosphere. When the air up there is really dry and lacks moisture, the contrail is very short. It's not a big deal. When the relative humidity in the upper atmosphere is very close to 100%, the material coming out of the high altitude jets then will tend to form that long condensation trail or contrail. And those scientists suggest could potentially reduce the daily temperature range between the minimum and maximum temperature in any given 24-hour period. As far as the ocean is concerned, we don't know enough about yet the ocean's impact on the climate system. Oceans have a large capacity to store and release heat, and they move much more slowly than the atmosphere does, which makes it difficult for climate modelers to find a model that will couple together the movement of the oceans and the movement of the atmosphere, because they move at different rates. Ultimately, the response of ocean temperatures and circulations will probably determine the global pattern and speed of climate change. What about consequences of global warming? Here are some that the IPCC says are possible. Land masses will probably warm up more rapidly than the global average, especially in the northern high latitudes in winter, due to less snow and ice on the dirt. That decreases the Earth's albedo. Modification of these areas due to warming will probably enhance the warming. That's a positive feedback mechanism we talked about earlier. Total rainfall would have to increase in order to balance the increased evaporation of water due to warming, but that increased rainfall would not be evenly distributed. You could see then more extreme floods and droughts, and they might be very closely juxtaposed to each other, and less precipitation in subtropical areas. Also, places that are accustomed to certain snow levels in the winter might have higher snow levels, same amount of precipitation, but perhaps more of it falling as rain instead of snow and at higher elevations, which means rain instead of snow, as I just mentioned. That might have an impact on irrigated agriculture, especially in areas like California, where we want all the snow we can get the wintertime, and then we want it to melt only when we want it to melt, not when nature wants it to melt, and to fill up our reservoirs so we can irrigate our crops. That could really be a game changer. The combination of glaciers receding over land areas and the expansion of water in the ocean simply due to the water warming up could cause sea levels to rise, and that could displace people, especially poor people who live in low elevations of the world, like, say, the mangrove swamps of Bangladesh, where a single tropical cyclone can easily wipe out 100,000 people. Rising temperatures in polar regions could cause changes in temperature, precipitation, and wind patterns as the ice decreases in those areas. Already, the North Pole has become navigable in late northern hemispheric summer, like August and September. That's recently been occurring due to less ice, more ice melting in those areas. Increasing carbon dioxide levels could cause some plants to become dominant and other plant species to disappear. You could have lower crop yields in the tropics, where, by the way, of course, agriculture is expanding, especially in the Amazon area in Brazil, where they're growing more sugarcane and more soybeans at the expense of wiping out the rainforests. And in the northern hemisphere, you could have higher crop yields due to the same kind of warming and maybe an expanded growing season in the northern hemisphere. This graphic shows A, projected surface air temperature changes using the A1B scenario that I showed you in figure 15.18. And B shows the changes that we experienced between 2001 and 2006 compared to the 1951 to 1980 averages. Now let's look at precipitation projections. This graphic shows in A the projected relative changes in precipitation in percent from the last decade of the century compared to the 1980 to 1999 average for both December, January, February, and June, July, August. Here's an interesting graphic from your book. The red line shows the extent of Arctic sea ice on the average between 1979 and 2000, and it shows what Arctic sea ice looked like in March 2005 compared to that average. Now let's go to September 2005. Again, the red line shows the average extent of Arctic sea ice in September for the period 1979 to 2000, but then the white shaded area shows the actual coverage of sea ice over the North Pole in September 2005. And there could be a race then if the North Pole is more navigable for whatever natural resources may be below the seafloor. Russia has already, with a robotic submarine, planted a flag at the bottom of the North Pole in the ocean there. There might be more frequent heat waves, more average days with maximum temperatures reaching exceeding 90 degrees Fahrenheit, and there might be more uncomfortable temperature-humidity combinations with more frequency. Most models predict wetter winters and drier summers over the northern hemisphere, including North America. Wetter winters could mean more flooding in mid to high latitudes over the northern hemisphere. We don't really know what global warming might do to the Asian monsoon, which is quite vital, as you no doubt already know. And the warming of polar regions could mess up the balance between the poles and the subtropics, which could have an effect on mid-latitude cyclones, the kinds of cyclones and storms that we have here in the mid-latitudes. Lake effect snowstorms might be less intense, but there might be a longer period for them to occur. It's not clear how warming might affect the frequency and intensity of thunderstorms over North America. Warming might make for a longer hurricane season. Obviously, the most practical way to reduce global warming is to reduce our use of fossil fuels, which the Kyoto Protocol attempted to do, but not all the industrial countries of the world actually agreed to it. Future work and meetings of the IPCC will no doubt focus on the latest and best science and future public policy. California's Assembly Bill 32 is the most aggressive public policy to reduce greenhouse gas emissions. And then there's geoengineering, but that could cause more problems, actually putting sulfate aerosols into the upper atmosphere every few years.